Hello everyone, a very good evening. Welcome back to my classes. Today we are starting with a new chapter that is mole concept and stoichiometry. So as we all know, for ICSE 2021, we have to do only a small chunk of this chapter because a large amount of this chapter has been removed. So we'll just stick to the syllabus of ICSE 2021. Let's begin with the chapter. So as a major portion of this chapter has been removed, so it's very probable to come in the examinations. So let's start. First of all, we'll do some terms which are there in the syllabus. First of all, let's do what is known as vapor density. Okay, let's start with vapor density. You'll come across this word many a times in the numericals as well. What is vapor density? Okay, now write the definition of this. It will or it may come in the examinations. Vapor density is the mass of volume. Okay, mass of volume, in the brackets you can write V, of a gas. Okay, under similar condition, under similar condition. Okay, next point about vapor density is the mass of volume. This is actually, I'll just give you the formula directly. Okay, so what is vapor density? Vapor density is the mass of volume of a gas divided by, okay, divided by the mass of volume V2, okay, of hydrogen gas. Hydrogen gas, or you can write at same condition. Okay, so what is this basically? This is, if we take any gas, let's take an example. We have taken a gas X, we don't know the gas. Okay, now we want to calculate the vapor density. So in order to calculate the vapor density, we'll divide this by the mass of volume of this X gas with the mass of volume of hydrogen. Okay, and these two should be in similar conditions, mean the temperature, the pressure should be same. So you just have to do what? You just have to do this formula for your examinations. If the definition also comes, you can just write that vapor density is the ratio of mass of volume of a gas under similar conditions to the mass of volume of a hydrogen gas at same condition. Okay, let's see the next thing, that is relation. Okay, so here also some relationship is there. So let's see the relation between, okay, relation of vapor density, let's write it in a short form, with relative molecular mass. So relative molecular mass, I hope that you all know what is relative molecular mass, isn't it? Because we have already studied that in class 9. So what is relative molecular mass? It's actually the mass of an element upon the total mass. Okay, that's only the relative molecular mass. Okay, and there is one more thing, that is relative atomic mass. Okay, that is something different. That is the mass of one atom of element divided by 1/12 mass of carbon C12 atom, isn't it? But that's not in your syllabus. So just now, just for now, just do the relation of velocity with vapor density with RMM, that is relative molecular mass. Write the full form if you want. Okay, what will be the full form of this? The full form of this will be actually the Avogadro number. Okay, what will it be? It will be 2 into velocity, vapor density, I'm sorry, vapor density, that is equal to the relative molecular mass. That is the relation. Can you see? 2 times the vapor density equals to the relative molecular mass. And this whole statement is actually called the Avogadro's law. Avogadro's law. Okay, I hope that it's clear. Let's move further. So now we move on to the next thing, that is the numerical part. Okay, because in this chapter you will not be getting many definitions. You just have to focus on the numericals only. Okay, definitions, you can just know what is vapor density and what is the relation of vapor density with relative molecular mass. So let's come to the numerical part. Okay, so first of all, let's divide this numerical part into two parts. Just give me a minute. Yeah, this is the numerical part. Okay, so let's divide it into two parts. Let's name it as part 1. Okay, in which we'll be talking about the various definitions. I hope that everybody is taking notes. Okay, so first definition which we have to keep in mind is of empirical formula, because empirical formula will be asked what is the empirical formula of this compound. You have to calculate that. Okay, first of all, you should be knowing what is the definition of uh, empirical formula. So let's write it down. Empirical formula. Okay, what is empirical formula? We have already dealt with it in class 9th also. So empirical formula of a compound. So let's write the definition that empirical formula of a compound. Okay, everybody is writing along with me, I hope. Is the simplest formula. Okay, it's the simplest formula. I'll give you an example and the whole definition will be clear to you. Is the simplest formula which gives, okay, which gives simplest ratio. Very important. Okay, and now a very important keyword is coming, because of which many students tend to lose their marks. That is simplest ratio in whole numbers. This is very important. Whole numbers. Okay, is it clear? Let's move on to the next. Whole numbers of atoms, okay, of different element present in one molecule. I'll give you an example and the whole this difficult definition will be clear in your mind. Present in one molecule of different elements, okay, of a compound. Let's see, let's look at an example first of all. Okay, so before coming to the example, I'll tell you one more thing, that is percentage composition. Okay, percentage composition. After this, I'll tell you the example. Percentage composition. What is percentage composition? It is the percentage composition, okay, is percentage by weight, okay, by weight of each element in a compound. Very important. Don't leave the class. Okay, it might be boring to you because you all are not taking down notes. I'll just give you an example and everything will be clear. Now let's take an example of glucose. Very important. Everybody must be knowing the formula. Who will tell me the formula? Please tell me fast. C6H12O6. Very good. Now, first of all, in order to calculate the empirical formula, we'll first of all take down the ratios. So I'll tell you the ratios. So as you can see, how many carbons are present? 6 carbons, 12 hydrogens, and 6 oxygens. So just write the same thing in a ratio format. Okay. Now, when you will calculate this ratio, So this okay. So since it is the empirical formula. Let's look at the formula again. See, originally it was C6H12O6, but now because of this empirical formula, it has turned into what? It has turned into C, because carbon is one. How many hydrogens are present? Two hydrogens are there, H2. And what is
CH2O.
the ratio of oxygen? Yes, CH2O. The same thing has now been transformed into this, because you have to just keep in mind these coefficients, write the ratios of these. Okay, next step will be simplifying the ratio, and then you are ready with your empirical formula. Okay, I'll tell you one more term here, that is empirical. So what is this empirical mass? Let's discuss that. So empirical mass is the sum total of every element present in this compound. Okay, so empirical means what? The simplest ratio. Yes, simplest ratio. What do we we have C, H2 and O. So what is the mass of one atom of carbon? Who will tell me?
12.
It's 12. So only one carbon is there, so 12 into 1 plus. Now next, what do we
16.
have? We have hydrogen. So it will be 1 into 2. Okay, because 2 hydrogen is present. Plus
16.
1 oxygen is there, so 16 into 1. Yes. What do we get? We'll get 12 plus 2 plus 16. That will be what? If we add the all the things, that will be 12 plus
30.
18, and it's
30
nothing but
MU.
30. Yes, it's 30. And that's the empirical mass. If anybody asks you in the examination, you'll say the empirical mass is this, and this is the empirical formula. Okay, let's now move on
Yes.
to another example. Example number 2. We'll now consider acetic acid. Now, by the name only, you must be thinking, why is he only giving organic compounds? Because organic compounds is the favorite of the examiners. It will come in the examination. Only the organic compounds they will ask. They will not ask of any other. Okay. So, what is the formula of acetic acid? Anybody?
COH.
CH3COH.
Yes, very good. Nice participation. So this is what? This is CH3COOH. Everybody has rectified it. Okay. Let's now see the ratio. How many carbon is present? Let's write them first. 2 carbon is there. So 2 carbon is 2. How many hydrogen is present? 1 hydrogen and 2 hydrogen. Okay. Here are actually how many hydrogen? 3 hydrogen, isn't it? 3 plus 1, 4. Okay,
4.
here is 3, here is 1. So 3 plus 1, 4. And how many oxygen is present? 2 oxygens are present, so 2. So this is the ratio, the first ratio which we have got. This is the ratio. Now let's simplify this ratio. What will we get?
1:2:1.
Is everybody getting? Anybody who's not, how are we getting this simplified version? Okay, so this is the empirical ratio or the empirical formula. Let's put it into this. This is empirical ratio. Right, let's write the empirical formula. What will be the empirical formula? The empirical formula will be C, only one C, 2H and one O, CH2O. Isn't it the same thing that we got in glucose? Yes.
Yes.
So it is same as glucose. And now you don't have to calculate in examinations, calculate it if it is asked, okay? But now we will not calculate the mass, it is the same. Empirical mass will be what? The same of glucose. So that will be what? 30. Same as glucose. Okay, now we are moving on to the numericals of this chapter. Very important part we have come to. So we'll discuss only 1 to 2 numerical, and from that only you will get the whole glimpse of the chapter and you will be able to do everything which is asked in the examination. Okay. So here's the first question in front of you. It says that there's an organic compound. So organic compounds contains of which elements? It usually consists of carbon, hydrogen, and oxygen. Okay. So this is also having carbon, hydrogen, and oxygen only. So what are we given? We are given the carbon percentage in it and the hydrogen percentage in it. Carbon percentage is 54.4 and hydrogen percentage is 9.13%. Okay. Now we have to determine the empirical formula and the molecular formula, and we have to calculate the mass of carbon. Okay, we have to calculate the mass of, not mass, we have to calculate the percentage composition of oxygen as well, because see, it's there but the percentage composition is not given, so we have to find it out. Okay, so let's start with the solution now. So solution, let's start. So what will we do? First of all, we'll calculate the percentage of oxygen. Without it, we will not be able to do anything. Okay, percentage of oxygen will be what? Now see, percentage, what is the meaning of percent? Cent means 100, isn't it? So we always calculate percent per 100 only, isn't it? So 100, let's say that the whole compound is 100. Okay, minus, in that we are having 54.4% of carbon and 9.13% of oxygen, isn't it? Now if we subtract it from it, then we'll be getting the percentage of oxygen, isn't it? Yes or no? Is it clear?
Yes,
Yes.
sir.
Chalo. So what will be the percentage of oxygen? The percentage of oxygen after calculating is 36.4%. Okay, that is all for oxygen. Now I'll be telling you a table which is super duper important. Without it, you will not do anything. Okay, and you have to draw the table with the same format. The format which I'll be teaching you, the same thing you have to draw in your examinations as well. Okay, so in this table, first of all, you have to write about the element, then you have to write the percentage composition of that element, then you have to write the atomic mass. Okay, then you have to write the atomic ratio, and then you have to write the simple ratio. Okay, then you have to write the simple ratio. Let me just write it clearly. Simple ratio. So let's draw the table. We all know all these data is given to us, so we'll be calculating which is not given. We'll just calculate it. Okay, so how to find it out? First of all, how many elements have we got? We have got carbon, hydrogen, and oxygen. The percentage composition is also given to us. Carbon is how much? 54.4. Hydrogen is how much? 19.13, 9.13, sorry. And oxygen, how much we have calculated just now? 36.4, isn't it? Mass. Atomic mass will be what actually? Atomic mass we all have been given in the question only. Atomic mass of carbon is 12.01. Atomic mass of
1.
hydrogen is 0.008, and that of oxygen is 16. Yeah, it's 1 only. Okay, it's 1 only. Let's treat it as 12 or that only. Okay, now next we come to atomic ratio. What is this atomic ratio? See, it is the ratio means have now got the empirical formula. Empirical formula will be what? See, we have got what? We have got carbon. The answer is 2. Hydrogen, the answer was 4, and oxygen is only your empirical formula. Okay, and this is the calculations which we did just now. Okay, now next. So next, now we move on to the empirical formula calculation. So what will be the empirical formula? C, how much C is there? 2. So C2. How many H is there? 4. So H4. Okay. And how many oxygen is there? 1. So 1 oxygen. Is it clear? Now this is what? This is the empirical formula. We have calculated one task. Okay. We have completed one task. Okay. Now next we move on to empirical mass. So empirical mass is what? It's not given in the question, but let's calculate because I've told you all. So what is empirical mass? Empirical mass is 12 into 2 plus 1 into 4 plus 16, isn't it? That's the only case. That will be 44. Okay, next let's move on to the next portion. Now we will calculate the molecular formula. So I'll just tell you that molecular formula is equals to empirical formula into n. Now you all must be thinking, what the hell is this n? So how will we calculate it? There's a long procedure. Let's do that procedure. We have to first calculate the relative molecular mass. Okay, so to calculate that, you have to first do what? First, the relative molecular mass equals to what? I've already told you in the beginning. What is the relation between empirical formula, between velocity, vapor density, and relative molecular mass?
2 into
2
vapor
into
density.
vapor density. Yes, that will be what? 2 into, that will be 2 into,
88.
what is the, yeah, that will be 88. Yes. So that will be 2 into 44. That is 88. Very, very good. Now, so relative molecular mass is what? RMM is that. Now the meeting will be ending in 1 minute.